In this video, I'm going to show you how to integrate secant x dx. You'll see the answer in two common ways, in two common forms, and you could just memorize these, and I highly recommend just memorizing these, but I'll also show you how to prove that both of these are true. Alright, so here's the first way I'm going to solve the integral of secant x dx. So this is actually also equal to the integral of secant x times secant x plus tangent x over secant x plus tangent x dx. So this right here is essentially just 1, but the reason we're adding this in is to make the computations a little bit easier. So now what we're going to do is we're going to distribute the secant x. So that becomes secant squared x plus secant x tangent x. The denominator stays the same. Now we can do a u sub with the denominator. So we set u equal to secant x plus tangent x, and du will be secant x tangent x plus secant squared x dx, which is the numerator. So this simplifies down to du over u, which we know is equal to the ln absolute value of u plus c, and now we can just substitute in our u. So our final answer would be ln absolute value of secant x plus tangent x plus c. And that is the first way you could solve the integral of secant x. Alright, so here's the second way to integrate secant of x dx. We're going to start by rewriting this as 1 over cosine of x dx. Now, we're going to multiply the top and bottom by cosine of x. So that's the same thing as multiplying by 1, but it'll make the math easier. Again, these are the exact same thing, I just multiplied the top and bottom by cosine of x. And the reason I want to do that is so that I can rewrite the denominator in terms of sign. So we'll leave the numerator cosine of x dx, and we can use our trig identities to convert the bottom to 1 minus sine squared of x. And so that's useful because now we can do a u sub by setting u equal to sine of x and du equal to cosine of x dx, which is the same thing as our numerator. So rewriting this in terms of u, we get du over 1 minus u squared. Now we can factor the bottom, so we can rewrite this again as du over 1 plus u times 1 minus u. And we're going to do that so that we can use partial fractions to solve from here. So let's set 1 over 1 plus u times 1 minus u equal to a over 1 plus u, and we're going to be solving for a and b here, plus b over 1 minus u. So now we're going to multiply everything by this term here. So we get a times 1 minus u plus b times 1 plus u. And we can set u equal to 1 to solve for b. So that's 1 equals, this becomes 0 plus 2b. So b is 1/2. And we can set u equal to -1 to solve for a. So 1 equals, this time this will become 0, and -1 minus -1 is 2, so that's 2a. And a is 1/2 as well. So since a and b are 1/2, we can now rewrite this integral with a coefficient of 1/2 using this split fraction. So that's going to look like this. The integral of 1 over 1 plus u plus 1 over 1 minus u. We have a coefficient of 1/2. And now we can evaluate this integral using we know that these will turn into natural logs. So this is 1 over 2. The first one will become ln absolute value of 1 plus u. And the second one will become negative ln absolute value of 1 minus u. And lastly, we can go ahead and rewrite this using log properties. So this is 1 over 2 ln, and when you have subtraction, you can turn that into division in one singular log. So that's 1 plus u over 1 minus u plus c. And our final step here is just going to be to convert u's back into what they originally were, which was sine of x. So that's 1 over 2 ln of 1 plus sine x over 1 minus sine of x plus c.